Right. Before I start this video, I just want to explain the whole setup. So I'm basically working off two screens. This is the smaller screen, and here's the bigger screen. That's why I'm looking away. I'm going to be improving on my setup, but for today, we'll just go with it. So the purpose of this video is text analysis, and this is a growing field that's only going to keep growing, especially with technologies like speech to text. So essentially, if you listen to a podcast and it's you use a speech to text software or it provides the speech to text, you can analyze that entire podcast in more detail by doing text analysis using Python. Or you can analyze regular text files, or you can analyze, yeah, like text files, or say you want to analyze a PDF or a book or a certain website report or review or surveys. The opportunities for this are endless. There's so much that can be done with this. But let's just get into this. As usual with Python, you have to call the libraries you will be using. Word tokenizer, I'm importing from NLTK, Natural Language Tokenizer. So word tokenizer is essentially I'm going to tokenize the words. I'll explain in more detail further down. I had to import this quadgram collection finder. I'll explain some more details as I go through the Jupyter notebook because it won't really make sense right now. I imported NLTK, imported Python PDF2. That's what this stands for. And why I imported this is because I'm working with PDF file. I don't have a standard text file. So I have to transform my PDF file into the text format before I can do the analysis. That's the only purpose of this. And this is what is going on here. I'm taking the PDF document that I have and turning it into transforming it into a text file for the purpose of analyzing it, doing text analysis. So you can the PDF I'm looking at that I'm analyzing today is a Johnny and Amber Depp. Johnny Amber Depp? Johnny Depp and Amber Heard case. I for whatever reason that was in my head yesterday, and I just looked up research journal on it, and this journal is kind of using it as a case study, but focusing on how um, society influences the way men talk to women. So look, I didn't. I just skimmed through the abstract, took the paper in, and just started to do the analysis on it. So let's see. Let's find out about. We're finding about this paper, and we're finding about this together right now. So yeah. So that's it. So if you have a PDF or a report, a work report that you want to analyze, you just have to paste the name in here, and then you can do the same analysis. You can follow along if you have a Jupyter notebook. If you don't have a Jupyter notebook, I will release another video where I show you how to use Google Colab, which means you don't have to go through downloading of the Anaconda system and learning. I will go through it. The video is going to be about 5 minutes long, and you'll be able to copy this in and do your own analysis of text. So after the PDF has been extracted, I've saved it into words. These are all the word. This is the PDF into text format with all the words. It's not laid out nice like with the abstract and introduction, conclusion, and these titles. It's just in the text format for analysis. It has to be in this format, so it's a sort of pre processing before you can get into the analysis. And then you have to tokenize it, more pre processing that has to be done before you get into the analysis of the text. So, tokenizing is just separating this into this text into individual words for analysis. And before we do the analysis, we have to do some more pre processing, which is removing stop words. I didn't get into it above. I think I got into it in previous iterations of this video. But so stop words is just filler words like I and that won't really help with the analysis. You want to make your whenever you're dealing with data analysis, the pre processing step is making it simple for the machine to understand. So I'm removing words like and I. And how I've done this is the NLTK corpus library has the words already saved in. This corpus has loads of text files in it that you can extract and do some analysis on. I decided to challenge myself by pulling, just because it's just, you know, pulling a PDF from online, a research journal, and just doing some analysis on it. I could have used way cleaner formats, but look, this is just, I think it really shows how cool this is when I can just pull a research paper from online and just start doing text analysis on it straight away. So yeah, back to what we're doing. So stop words, it's saved under stop words, and I've saved this under this variable so I can use it to remove further down. So two things are happening here in this filter token variables. This filtered tokens variable. What I've done is I have stop words being removed, and I've changed all the tokenized words, the individual words that we've extracted by using word tokenize, change them into lowercase, and if it's not in stop words, it will remain in lowercase and be added to filter tokens. That's what's going on here. So it will go through the all the tokens, this loop, and check, is it in stop words? No, okay, lowercase. So we've lowercase all the words. Why are we lowercasing this? Because Python sees each word, the uppercase and the lowercase version, as separate words, and that doesn't help our analysis. Say we're looking for the word, we have the word chicken. If it has a capital C and lowercase c, and we try to say how many times does the word chicken come up in this report, how many times did Johnny Depp say, "Oh, you're chicken" or something, it will give the capitalized version as 6 times, whatever, how many ever times that shows up in lowercase as another version, and that doesn't help our analysis. So we're transforming everything into lowercase to make it to get a better picture of what really happened, to improve our analysis. And further down, then we have to NLTK text the token. So the filter token variable that we create above we then have to use the NLTK text to transform it, and then I've saved on the TK words. Why we're doing this is to add functionality into it. Now we can look at a frequency distribution of the text. So now I go NLTK dot frequency distribution on my TK words that I've NLTK text above. It's just a pre-processing step that we have to do. And now the frequency distribution, I've used most common, and I'm looking at the 20 most common words in the entire text. Straight away, boom, that takes seconds to run. Seconds, and you have the most common words in the entire. Now imagine you're looking at a book. You have a big long book and you want to look up the most common words used, the top 20. You can just look up the top 50, and so you can really see the power in this. Like, the opportunities for analysis are, it's as wide as your imagination, essentially. And now we tabulate it. I don't think this looks great, but yeah, so you can, it's just it in table version. And now, if you're looking for a specific word in a big long report, or say you speech to text a podcast, and you're trying to find out what was it, was someone, say someone was mentioned, like in a podcast, like say, for example, Joe Budden has a problem with Charlemagne. Did he mention Charlemagne in the entire podcast? You can do something like this if you can get a speech to text. But here I'm looking up hit. So, you know, was like, did this journal get into the physicality between Amber Heard and Johnny Depp? And it does, one time. So we know it's not the focus. Remember, the journal is focused on the speech, how society influences the way men speak to women, but they still mentioned physical abuse. Depp loses bid appeal, son revealed hit her 12 times. So that's something that's brought some context. So that's what it does. The concordance brings context to this. So you find a specific word you're looking for, and they'll tell you how many times that word comes up, and then we can look at concordance to add context to it. So quick analysis. And now, say we want to find out connection of words to give more context, like a trigram, so tree words, and top 5 most common tree words in connection. This will find it. So obviously, Johnny Depp and Amber, This came up 37 times. This was the top five. We can look up to 20. We can change this to diagram for 2 words. Probably won't get enough context in that, or quadgram for 4 words. So you can see the power of this analysis and what you can do with this. This is top 20. And for the Finder 2, I created a quadgram and Johnny Depp and Amber Heard, obviously. So just like that, you can quickly analyze reports or podcasts. The opportunities are endless. I think this is amazing, and I'm definitely going to be looking at more text, more reports, and this can even help you in work. So look, hope this is helpful. Like and subscribe to say thank you. And if there's something you'd like me to improve upon, leave a comment. Let me know so I can keep improving and making better videos that will just make data analysis easier for everybody. Thanks for watching.